4.3. The ambiguous case of the sine law. If we're given an acute angle, say angle A, an adjacent side, say B, and an opposite side, say side A, then if angle A is acute and side A is less than H, there is no triangle. Here's a nice picture to illustrate that. If angle A is acute and A is equal to H, then there's one right triangle. If angle A is acute and A is bigger or greater than side B, then or if A is equal to B, then there's one triangle. If angle A is acute and A is greater than H but less than B, then there are two possible triangles. If angle side A, and side B are given, and angle A is obtuse, then there are two possibilities to consider. If angle A is obtuse, and A is less than B or A is equal to B, there is no triangle, because A just hangs there. If angle A is obtuse, and A is greater than B, then there's one triangle. But for these to be helpful, we need to know how to find H. Well, if you look back up here, H is actually equal to sine A is equal to H divided by B. How do I know? Because sine is opposite over hypotenuse. So then B sine A is equal to H. So in summary then, in a triangle with acute angle A, no triangle can be drawn if A is less than B sine A. One triangle can be drawn if A is equal to B sine A. Two triangles can be drawn if A is greater than B sine A and A is less than B. And one triangle can be drawn if A is greater than B sine A and A is greater than or equal to B. Let's look at an example. Determine whether there are 0, 1, or 2 possibilities for each example where the angle is 30 degrees and an adjacent side is 12 meters. So the first thing I have to do is I have to find what H is going to be so that I can compare it to A. So I drew my triangle and solved for H. So here's my triangle. I have angle A is equal to 30 degrees, B is equal to 12, and I need to solve for H. So H is equal to B sine A, H is equal to 12 sine of 30 degrees, H is equal to 6 meters. So, set part A. I need to determine whether there are 0, 1, or 2 possibilities. A is 30, angle A is 30 degrees, side A is 4 meters, and B is 12 meters. So I drew myself a picture. A is less than B, and it's also less than H, so that means that there are going to be no triangles. Part B, my angle stays the same and my adjacent side stays the same, but now my opposite side is 6 meters. A is less than B and equal to H, so there's only one possible triangle because my A is equal to my height. So there's only one. Part C. My angle stays the same, it's 30 degrees. My adjacent side stays the same, it's 12 meters, but now A is 8 meters. A is actually less than B, because 8 is less than 12, and A is greater than H. 8 is greater than 6. So there are two possible triangles. D. Now A is 15 meters. A is bigger than side B, so there's only one possible triangle.